Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 8th March 2023. The problem statement for today is max min height. This problem is based on binary search and arrays concept. Let's now open this problem. Let's understand the given problem first. Here it is said, you have a garden with n flowers lined up in a row. The height of ith flower is AI unit. You will water them for k days. In one day, you can water W continuous flowers. You can do this only once in a single day. Whenever you water a flower, its height increases by 1 unit. You need to maximize the height of the smallest flower of all time. So here it is simply said that we will be provided as an input n, that will be the n flowers lined up in a row, and we will be provided and in each row the height of the flower is represented by the given array A, where AI represents the height of ith flower. We have to water them for k days, so the k is again given in the input, and in one day we can only water W continuous flowers. So even that series will be given in the as an input, and whenever that any flower is watered, so the height increases by 1 unit. So we have to somehow maximize the height of the smallest flower of all the time. I hope this the problem statement is clear. So now let's go through this example first. Here it is said that n is equal to 6, k is 2. K is 2. What was k? We have to water them for k days. That means we have to water them for 2 days. And the number of flowers that we can water continuously, the number of flowers that we can take to water in a particular day, that is 3. That means 3 continuous flowers we can water. And the height of all the flowers that is given in array A. So here it is said that since the number n is 6, so here we can see the height in this array contains 6 heights. So it is said that initially for flower 1 to 4 the height is 2, and for 5th and 6th the height is 1. So the output here is 2. Here it is said that water last 3 flower for first day. Water last 3 flower for first day and first 3 flower for the second day. The new height will be 3 3 3 3 2 2. So he say here as it is mentioned in the question that we have to focus on maximizing the height of the smallest flower all the time. That is the only reason that it has been taken that we have to first water last 3 flowers on the first day, which is this 2 1 1. We have to first water this sequence, then we will go to the remaining one, because we have to always maximize the smallest flower one. Okay, so I hope this is clear. So let's look at the second example as well. Here it is given that n is equal to 2, that means 2 flowers are there. We have to water them for 5 days, and the number of sequence in the series sequence in which we can water is maximum 2 is 1 only. W is 1 only. So we can water for 5 days, but 1 flower only at a time. So here it is said that and there are only 2 flowers. So this height array that consists of 5 and 8. So the output is 9. How it is that? For the first 4 days, water the first flower, because the minimum of 5 and 8 is 5. So we have to target watering the flower which is minimum in height. So for the first 4 days, water the first flower, then water the last flower once. So for the first 4 days, when we will water it, so the height will become for the first flower where the height is 5, it will become 9. So now the smaller one is the second flower, not the first flower. So for the next day we have to water the smaller one. So then the height of it will become 9 as well. So I hope the given problem statement is very clear. So here to solve this problem, the algorithm we will use is binary search based algorithm. So here are some of the steps which we will follow in solving this problem. We will initialize some variables. We will set the initial value of minimum height, that we will call it as mini, to the minimum height of the flowers in the garden, and set the initial value of the maximum height, that we will call as maxi, to a very large number. Then we will perform a binary search while the minimum height is less than or equal to the maximum height, we will do certain operations. What are those certain operations? We will try to guess a height which will be the average of mini and maxi. That means some kind of predicted height. Check if it is possible to water the flowers for k days and achieve the minimum height of the guess height for the smallest flower using the function is possible. So I will show that function as well. If it is possible, then update the answer with the current guessed height value and update the mini to the current guess height plus 1, else update the maxi to the current guess height minus 1. Return the maximum height possible for the smallest flower. Once the binary search is completed, the answer will contain the maximum height possible for the smallest flower that can be achieved by watering that flowers for k days. I hope the approach is very clear. So just to save time, I have already prepared a solution. I'll just copy it and I'll try to explain it line by line. So Control A, Control C. So here what we have done in this, so again as we have discussed, we have tried solving it using binary search approach. We need to find a maximum height possible for the smallest flower by watering them for k days. To achieve this, we can perform a binary search on the range of possible heights. I hope this is clear. So let me drag it a bit so that all the comments are visible here. I'll just put, okay, I think rest of all the comments are properly visible. So I have tried giving comments as well so that this solution becomes self-explanatory. So here what we are doing, first we are initializing the answer to -1 and find the minimum height of all the flowers using the arrays.stream a of minimum, and we are converting it to integer. I hope this is fine. Now we also initialize the maximum possible height as integer of max value by 2. Then we enter a loop that continues until the minimum flower is less than or equal to the maximum height possible. This one. So for this reason only we are performing this while loop here. Inside this loop, we calculate a predicted height or a guess height, which is the midpoint of the minimum flower height and maximum possible height. We use this guess height to check if it is possible to water the flowers to achieve the desired minimum height using each possible method. If it is possible, then we update the guess flower height and set the minimum flower height to guess height plus 1. Otherwise, we set the maximum possible height to guess height minus 1. Okay, and here if it is done, then whatever the answer we have got, that we are returning in this one. Looking at this is possible method. So is this possible in the method, this one, the is possible method is used to check if it is possible to achieve the desired minimum height using a given number of days and number of contiguous flowers that can be watered in a single day. So we have calculated this guess height here, so which we are passing to this one as a minimum height, and we are trying to find out by that if we are watering the flowers for these many days and these many continuous flowers will we be able to achieve that minimum height. So this we are checking. So in this one it calculates the water supply required to achieve the desired minimum height for each flower and check if the number of days required to water all the flower is less than or equal to the given number of days. So here what we are doing in this one, so here we initialize the array of water supply, this one, this one, water supply for each flower and initially set it to 0. If the height of the first flower is less than the desired minimum height, then we calculate the water supply required to achieve the desired height and update the number of days accordingly. If the number of days becomes negative, then we return false, as it is not possible to achieve the desired minimum height in the given number of days which we have passed through this function. Then what we are doing, so for each subsequent flower we calculate the actual height of the flower based on the previous water supplies and the number of contiguous flowers that can be watered in a single day. If the actual height is less than the desired minimum height, we calculate the water supply required to achieve the desired height and update the number of days accordingly. If the number of days become negative, here as well, we are following the same approach, here also, if the number of days become negative, then we return false as it is not possible to achieve the desired minimum height for the given number of days. If we are able to calculate the water supplies for all the flowers and the number of days required is less than or equal to the given number of days, we return true, indicating that it is possible to achieve the desired minimum height in the given number of days. Finally, we return the answer, which is the maximum possible height of the flower, which is this one in this step. So finally we return the answer, which is the maximum height possible for the smallest flower that can be achieved in the given number of days by watering them. I hope this approach is very clear, and this explanation also. So I've tried giving comments in each step so that even this solution becomes self-explanatory. Okay, so now let's try compiling this code. So here we can see we have got our output correctly. Here it is, the output is 2, which is the desired one. Let's try submitting the solution. So here we can see it has cleared all the test cases and this problem has been solved successfully. So talking about the time complexity of the solution which I provided, it is big O of n log h, where n is the number of flowers and h is the range of possible heights, which is proportional to the integer of max value. The binary search approach takes big O of log h time complexity to find maximum height possible for the smallest flower. For each guess height, the each possible method is called, which has a time complexity of big O of n. Therefore, the overall time complexity is big O of n log h. In practice, the range of possible heights is much smaller than integer.max value. So in actual time complexity is much lower than the worst time complexity. So I hope even this explanation is clear. Yeah, so I'll be providing the link for this question in the description box. Please do check that. That's all in this video. Please like, comment and share the video, and please subscribe to the channel for more upcoming videos. Thank you for watching.